Assalamualaikum warahmatullahi wabarakatuh and greetings to all AP students. So today we are going to learn about the alkenes because last Wednesday we have finished the topic of alkenes. So now we are going to start for the alkenes topic. So let's see what are inside this topic. Okay, for the first one, okay, we look the subtopic in these alkenes. Okay, the first one is introduction, and then nomenclature, physical properties, preparation, and also the chemical properties. The chemical properties is actually the reaction of alkenes. All right. So for this lecture, we are going to discuss for the introduction and the nomenclature only. All right. Okay, let's go for the introduction first. Okay, this is lecture 5 lah. Right. So the alkenes are unsaturated hydrocarbon due to the presence of double bond. One bond is the sigma and another bond is the pi bond. Okay, and this double bond is the functional group of the alkene. So by comparing these two type of the bonding, the sigma bond is stronger. Okay, the sigma bond is stronger compared to the pi bond. Pi bond is easily to break, so it is very reactive to undergo the reaction, especially the addition reaction. All right. So the presence of the double bond causes the alkene loss to hydrogen atoms compared to corresponding alkane, and hence the general formula for the alkene is CnH2n. So CnH2n ni juga since it is lost to hydrogen atom, meaning that the alkenes is unsaturated. Kenapa kita cakap dia unsaturated? Because it can gain the atom, or it can undergo the addition reaction because it has the double bond. Okay, the electrophile can be added to the double bond, so it will be the saturated compound lah. For example, kalau kita tambah hydrogen, dua hydrogen H2, alright, so dia akan jadi alkene lah. Kita tambah halogen, dia akan jadi haloalkane. So all this type of the reaction kita akan discuss in the last topic of the alkene, which is the chemical properties of the alkene. Alright. And if you see to this molecular formula, remember that this molecular formula is similar to the molecular formula of the cycloalkane. Okay. So since the molecular formula is the same, therefore the alkene and cycloalkane is the functional group isomerism. Okay. And the presence of double bond is a must in the alkene, so the simplest alkene exists as 2 carbon, which is ethene. Okay, it's a simple statement lah. Okay, next. Nomenclature. Okay, this is second subtopic in this topic. Okay, alkenes are named by substituting the ending of the "-ine" in the name of the corresponding alkene with "-ine". Okay, so kita tukar dia punya suffix. Okay, this is the suffix of the alkane, this is suffix of the alkene. Okay, alkane, alkene. So kita tukar "-ine" kepada "-ine". Alright, the alkenes with 4 or more carbon atoms have positional isomers. Thus, the additional rule is needed to name the alkenes. Okay, so kalau you ingat lagi, in previous topic, which is the alkane, kita cakap the alkenes do not apply the locane. But in this alkene, the locane is very important to specify the location of the double bond. Okay, the primary functional group kat sini, in this topic, is actually the double bond. Okay, kalau kita baca kat bawah ni pun, the location of the double bond is shown by a number. The numbering start from the end of the longest chain containing the double bond that give a lower number to the carbon-carbon double bond. So kita tengok satu persatu, step by step, how to name the alkene. Okay, step number 1. Name the parent hydrocarbon by locating the longest carbon chain that contains the double bond and name it according to the number of carbons with the suffix "-ine". So kalau kita tengok in this example, actually these are the same structure. These two structures are the same compound. Okay, the same compound, but with different color lah. Okay, saya warnakan berbeza because for the molecule on the left, okay, I consider 1, 2, 3, 4, 5, 6 as the longest carbon chain. But for the molecule on the right, I considered 1, 2, 3, 4, 5. Only 5 as the longest carbon chain. So which one is the correct numbering? Actually, you can number both. Okay, but if you consider this one, okay, so the longest carbon chain containing the double bond, so that the name is pentene. Okay, the name is pentene. But if you consider this one, okay, this one, the longest carbon chain do not contain the double bond. Double bond is just the substituent. Okay, so this cannot be the hexene. Cannot be the hexene. It should be the hexane. Kalau hexane betul. Alright. So the answer is pentene. Okay, choose the correct name. The answer is pentene. But note that the hexene is wrong, but the hexane is correct. Okay, hexane is correct. So itu adalah penamaan lain bagi this compound. Okay, macam saya cakap tadi, this one can be substituent. Okay, nama substituent ni adalah methylene. Okay, methylene. So maybe kita boleh namakan ini sebagai 3-methylene hexane. Okay, but sekarang ni since kita nak fokus pada the nomenclature of the alkene, not the hexane anymore, so kita focus on this type of nomenclature. But both are correct. Kedua-duanya sepatutnya betul. Okay. Step number 2, number the carbon of the parent chain so that the double bond carbons have the lowest possible number. Okay, so tadi kita dah namakan sebagai pentene, tapi tak lengkap lagi because we do not assign the locant or the position of the double bond. Okay, so kat sini kita kena tentukan the position of the double bond. 1, 2, 3, 4, 5, 6. So the double bond is at the carbon number 4. So this one will be the hex for in. But if we numbered from right to the left, 1, 2, 3, 4, 5, 6. Okay, the double bond is at the carbon number 2. So this one will be hex to in. So which one is correct? Okay, dia cakap kita nak the lowest possible number. So this one is the correct answer, hex to in. Alright, next. Step number 3, write out the full name, numbering the substituents according to their position in the chain and list them in alphabetical order. Indicate the double bond by number of the first alkene carbon. Okay, if the double bond is equal from each side, so kita akan bagi the lowest number for the substituent. Okay, the lowest number for the substituent. So you look at this structure: 1, 2, 3, 4, 5, 6, 7, 8, right? And this numbering: 1, 2, 3, 4, 5, 6, 7, 8. Okay, kat sini is quite confusing. Kenapa quite confusing? The first one, the position of the double bond is maintained. Doesn't matter you number from the left to the right or from the right to the left, the position of the double bond is still at the carbon number 4. Okay, this one and also this one. Okay, the position of the double bond. So the locant is 4. Okay, so ox for in. Okay. Satu lagi, kenapa this one is so confusing? Because the position of the substituent is also the same. You look at the red color. Okay, the red color. The position combination is 3 and 6. Okay, 3, 6. The same goes to the green color. The position of the substituent is 3 and 6. Also 3 and 6. So which one we need to choose? Okay, now we go to the next step, which is what is the name for the substituent? So this one is the ethyl and this one is the methyl. Right, this one. Okay, so ethyl start with E and methyl start with M. E comes first before M, so E will have lower number than M. Ethyl will have lower number than metal. Okay, so the green color is the correct numbering. Okay, not the red one. Okay, settle yang itu. But you look at the next compound. Okay, the next compound. Okay, kita tengok pula yang ini. 1, 2, 3, 4, 5, 6, 7. The green 1, 2, 3, 4, 5, 6, 7. Alright. For the red color, the locant at the carbon number 3. Okay, the position of the number bond at the carbon number 3. But for the green one, the position of the double bond is at the carbon number 4. So yang ni senang, tak confuse. Pilih yang mana? Pilih yang the lowest number of the locant, which is the red color. So yang ni kemenangan pada warna merah. Alright, so let's see the name for these two. Alright, so the first one is 3-ethyl. Okay, betul Kita tengok tadi yang hijau ni, numbering hijau. At the carbon number 3, we have ethyl. 6-methyl. At the carbon number 6, this is carbon number 6, we have metal. Oct 4-in. 4 is the locant, okay, which is the position of the double bond. Okay. As for this one, okay, kita consider for the red numbering. Okay, 5-ethyl or ethyl. Okay, 5-ethyl. And 2-methyl. Okay, Hept 3-in. The locant is 3. Alright. Next. If more than one double bond is present, indicate their position by using the number of the first carbon of each double bond and use the suffix di-in, tri-in or tetra-in depending of the number of the double bond. So kat sini kita tengok 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So the red color will give the locant as 1 and 3. Okay, 1 and 3. But for the green color, the locant will be 2 and 4. 2 and 4. So this is a bigger number. So this is wrong. Salah lah. Bigger number. So this one will be penta 1,3 di-in. Okay, 1,3 yang betul. Okay, penta 1,3 di-in. Kenapa di-in? Because 2 double bond. Okay, next is cycloalkene. Okay, number the cycloalkene, so the double bond carbon gets the number 1 and 2 and the first substituent is the lowest possible number. Okay, kita tengok numbering dia 1, 2. Macam mana pun mesti 1, 2. So clockwise 1, 2, 3. The substituent at the carbon number 3. But if you rotate anti-clockwise 1, 2, 3, 4, 5, 6. The substituent at the carbon number 6. So the red color is wrong. Salah. Okay, penomboran merah tu salah. Alright. So the name for this cycloalkene will be 3-propyl cyclohex 1-in. Okay, at the carbon number 3 we have propyl group. Okay, and this is cyclohexene. Okay, this is cyclohexene. And kat sini I note juga it is not 2-propyl cyclohex 1-in. Okay, sometimes kita number 1 dekat sini, 2 dekat sini. Okay, so jadi 2-propyl, salah. Because the double bond must be carbon 1 and 2. Okay, dia mesti lalu double bond. Tak boleh start daripada hujung double bond terus pergi pada propyl tu, tak boleh. Alright. Next. Okay. If there is a substituent on one of the double bond, it gets the number 1. Okay. So kita dah tahu tadi, kita mesti lalu double bond. Okay, kita mesti lalu double bond. So kat sini kita confused. We want to start 1, 2, 3 ke atau 1, 2, 3, 4, 5. Okay. So yang mana satu? Adakah 2,3 dimethyl cyclopene 1-in yang ini ke ataupun 1,5 dimethyl cyclopene 1-in? Okay, yang hijau ke yang biru yang betul dia punya penomboran? Okay. So, kalau kita baca statement ke atas, the substituent on one of the double bond gets the number 1. So substituent ni akan dapat nombor 1, which is the grade 1. So walaupun combination 1, 5 is much more bigger than 2, 3, okay, lagi besar daripada 2, 3, but this is the correct numbering for this type of cycloalkene. Okay, 1, 5, dimethyl cyclopents 1 in. Okay, bukan yang ini. Because the substituent must given to carbon number 1. Okay, next. If there are combination of alkene and cycloalkene in the molecule, the nomenclature will be as follows. Okay, yang ni saya terus bagi jawapan. Saya tak berteka-teki sebab kita nak bincang. This is quite complicated. Okay, you look at this. Kita mesti start the numbering from the kita nak bagi nombor yang paling kecil for the double bond. So kat sini kita start from here. 1, 2, 3, 4. Kita tak start daripada atas. 1, 2, 3, 4. Okay, kita start dari bawah. But this one, kita tak start dari bawah. We start from the top. 1, 2, 3, 4. Because we want to give the lowest number of the locant, which is the position of the double bond. So the position of the double bond doesn't matter here or here, it always be number 1. So it's always 1 in, 1 in. Okay, it's always 1 in. But the difference between these two molecules is the position of the cycloalkyl, okay, or cyclobutyl. Okay, this cyclobutyl, okay, is located at the carbon number 1. Therefore, the name is 1-cyclobutyl but 1 in. Okay, but as for this one, the location of the cyclobutyl at the carbon number 4. Therefore, the name is 4-cyclobutyl but 1 in. O ni is the another name for this compound. Ini nama lain dia. Okay, di mana kita jadikan the cyclobutane as the parent. Okay, kita jadi cyclobutane as the parent and this alkene sebagai dia punya substituent. Okay, kita jadikan dia sebagai substituent. But this type of nomenclature is quite complicated. So for your level, just focus on this type of nomenclature. Tapi ini juga betul. But tak perlu nak fokus for this time. Kalau you sambung later on in chemistry as a major ataupun something as the course that related to chemistry, so you will learn further about this. Alright? Okay. These are some examples of alkene as the substituent. Kan tadi saya cakap alkene juga boleh jadi substituent or join the acyclic chain to the cyclic ring. So ingat tak tadi yang the first step tadi, okay? Kita cakap C double bond CH2 ni actually CH2 kat hujung dia ni. Okay, cuma kita tak tulis. Okay. So C double bond CH2 ni apa nama dia? Nama dia adalah methylene. Okay, methylene. Okay. So this is cyclopentane, so nama dia methylene cyclopentane. Alright. Kalau ada dua karbon jadi ethylidene. Okay, ethylidene. Tapi kalau this double bond kita pindah ke sini macam ni, kita pindah ke sini, dia bukan lagi jadi bridging. Yang ni dia bridging. Okay, dia bridging join the acyclic to cyclic. Okay, dia menghubungkan antara kumpulan acyclic kepada kumpulan cyclic. Okay, this one dia dah tak jadi bridging. So, ini nama special dia adalah vinyl. Okay. And kalau 3 karbon, ini nama special dia adalah allyl. Okay. Sebenarnya ada banyak nama-nama special macam ni. But enough for your syllabus, I give these four of the special name of the alkene as the substituent. Okay. Tak perlu banyak sangat. Okay, nanti confuse. Alright. Okay. Lagi. Alkenes ni sebenarnya dia boleh bentuk geometrical isomerism. Kenapa? The first one, sebab dia ada restricted rotation. Okay, kenapa ada restricted rotation? Because it has a double bond. Okay, restricted rotation ni kita dah belajar ada dua sebab. Disebabkan oleh double bond and also disebabkan oleh cyclic ring. So in this topic, the restricted rotation is due to the presence of the double bond in the alkene structure. And syarat yang kedua, yang ni not all alkene akan patuhi. Okay, kalau syarat pertama tu semua alkene akan patuhi. But syarat kedua, have two different atoms or group of atom in each end of the carbon that exhibit restricted rotation. So kalau kita tengok the three structural isomers of the C4H8, but 1-in tak boleh jadi geometrical isomerism because at this end we have two hydrogen. Kat sini boleh, we have hydrogen and also ethyl. Boleh. Okay, kat sini boleh. Tapi kat sini bermasalah. Two hydrogen. Two metal prop 1-in. Lagi teruk. Because both side ada kumpulan yang sama. Sini dua-dua hydrogen. Sini dua-dua metal group. So, memang sangat-sangat tak boleh nak jadi geometrical isomerism. But how about this? But-2-in. We have hydrogen and metal. Also same here, we have hydrogen and metal. So we have two different atom or group of atom. Atom to hydrogen lah, group of atom to metal. Alright? We have two different atom or group of atom at each end, kedua-dua hujung. Okay, C ini dan C ini at each end of the carbon that exhibit restricted rotation. Yang ni hanya satu hujung, so tak boleh. Ini dua-dua hujung pun tak boleh. Alright, so ini kedua-dua hujung boleh ada dua atom ataupun group of atom yang beza, so dia boleh mengalami geometrical isomerism. Apa dia geometrical isomerism? Dia boleh bentuk dalam struktur cis and trans. Okay, so the cis structure, okay, the alkyl group is on the same side while the hydrogen group is also on the same side. Okay, same side. Manakala for the trans structure, the alkyl group is opposite to each other. Same goes to the hydrogen is also opposite to each other. So what is the effect of this arrangement? Apa kesan dia kalau dia duduk bertentangan atau duduk bersebelahan? Dia ada beberapa kesan. Okay, kita cakap kat situ, both have similar chemical properties but slightly different in the physical properties. Okay, contohnya macam stability dia berbeza. Dia punya boiling point dia pun berbeza. So, boiling point tu nanti kita belajar in the physical properties punya topic, which is lecture 6. Okay, so now I will go for the stability lah dulu. Okay, kita pergi pada stability dulu. Cis versus trans. So, agak-agak yang mana lebih stabil? Okay, so kat sini ada statement kat situ, the trans alkenes are generally more stable than the cis alkene. Okay, and the stability of an alkene increases as the number of the R group under CC increases. Okay, kita tengok statement yang pertama dulu. Okay, this is the first statement. Okay, kenapa cis alkene is less stable than the trans alkene? So kita tengok the structure of the cis alkene. The metal group is a big group. Okay, kita panggil sebagai bulky group. So bila bulky group, the electron cloud between these two group will repel each other. Okay, so kita panggil dia sebagai dia ada steric interaction between two bulky group. Okay, dia ada interaksi yang electron cloud yang sangat-sangat besar. Okay, menyebabkan dia jadi tak stabil sebab dia saling menolak. Okay, repel to each other. Okay, but for the trans structure, the bulky group is further away from each other. Dia berjauhan. Okay, dan dekat sini dia ada apa? Dia ada hydrogen. Hydrogen tu kecil je. Okay, hydrogen tu kecil. Okay, so dia punya repulsion tu kurang lah. Less repulsion compared to the cis structure. So bila dia kurang penolakan, so dia lagi stabil. Okay, yang ni ada berlaku penolakan. So it is less stable. Alright. Okay, itu statement yang pertama. The second statement, the stability of an alkene increases as the number of the R group on the C double bond C increases. So, kalau kita tengok kat sini, kenapa 1-butene paling rendah dia punya stability? So, the least stable among these three. Okay, sebab 1-butene kat sini dia ada H. Kat sini H dan sini H. So, dia ada 3 H dan dia punya kumpulan alkyl, the R group is only this one. Only one alkyl group which is ethyl. Okay. Sedangkan the cis and trans butene, kedua-duanya mempunyai dua alkyl group. So this is the R group. Ada dua. Okay. So dua alkyl group ni menyebabkan dia lebih stabil. Kenapa? Because the alkyl group is the electron donating group, which is stabilize the double bond. Okay. Dia adalah kumpulan penolak elektron. So paling tak stabil adalah but1-in. Okay. Diikuti oleh cis but2-in, diikuti oleh trans, okay, but2-in yang paling stabil. Okay, I think that's enough for this lecture. Okay, until we meet again in the next lecture, which is about the physical properties and also the preparation of the alkenes. Okay, that's all. Thank you.